Okay, here we are on question 2 of exam 2 for electricity and electronics. So we've got a simple circuit here, 3 resistors, all labeled with the subscripts. You've got an AC source, and we're told the value of all the resistances, so they're all each 20 ohms, and the RMS voltage of the AC source is 12 volts, and the frequency of the AC source is 100 hertz. The first thing we're asked to do is calculate the peak voltage applied to the circuit by the AC source. We have an equation that relates RMS and peak values for AC, and it goes like this. So VRMS is equal to square root of 2 over 2 times V peak. And that means that if we go ahead and solve for V peak here, then we get VRMS divided by square root of 2 over 2. And that in turn gives us 12 volts divided by about 0.707, which gets us to about 17 volts, just under, being the peak voltage. All right, so it's a nice simple calculation there. Just need to know what you're doing with that equation, you'll be fine. Next one, total RMS current flowing through the circuit. So if we want to find the total current, we want to find the total resistance and the total RMS voltage. And going through that, just from Ohm's law, we know that IRMS is equal to VRMS over R total. Remember that R doesn't really care about AC versus DC, so there's no RMS value for that. So we've got 12 volts for the RMS voltage applied to the circuit. That's the total voltage from the AC source. We don't know the total resistance though, so we go and find that. We have one resistor 1 that's in series with the parallel combination of 2 and 3. So what that looks like in our equation is R1 plus the parallel combination of R2 and R3. So we got that. And then what we need to do is substitute in the values of the resistance. That's really easy to do in this case because we're told that they're all the same value. And this turns out to be 30 ohms total resistance. And the total resistance then comes right over here. We plug that in. And if we look at that, we can divide 3 into both of those. So we have 4 over 10 for 4/10 of an amp. All right, and you hear my lovely child waking up from her nap. Hopefully I didn't wake her up. I'm not speaking that loudly, but I suppose you never know. Okay, so we have one last task to do, and we want to draw 2 traces, one showing the total voltage versus time applied to the circuit, the second showing the voltage versus time applied to R2. The graph should be reasonably close to scale. Okay, so first of all, remember that our frequency for this AC signal is 100 hertz. So the period is 1 over that. So the period is 0.01 seconds. So the period will repeat once every 100th of a second on the x-axis. So that means we can go up to peak, back down to 0, and then down to a trough, and back to 0, and then up to a peak, and then like that, and like that, and like that. So the 1 voltage signal will be, I'll make about that tall, and that will create a sine wave kind of like this, okay? And if we want to label this one appropriately, we call that the full voltage, and that peak value then would be 17 volts, just what we found in part A. And then in part Well, actually, we didn't find in part B was about the total resistance, or sorry, total resistance and then RMS current, right? So if we go back up to the diagram, though, we can look at that and say, okay, well, remember the R2 and R3 had 10 ohms together in a parallel, and that 10 ohms is in series with this 20 ohm resistor here. So in terms of the voltage dropping across R2, the one that we're interested in for part C, that's going to be 1/3 of the total voltage applied to the circuit at any moment in time. Okay, so move back down here. Okay. Then if we measure to maybe like, I'm going to say that that's about the 1/3 way point up from the axis. Okay, so we label that whatever 17 divided by 3 volts is. Okay, don't have to be that specific, but just to give us an idea. And we again have our sine wave repeating here, back and forth and back and forth. And I'm going to make it a dotted line just to separate it from the other one. And there we go. So this one, this dotted line, is the one that's being dropped across R2, and you'll note that I've tried to draw it so that it's always dropping 1/3 of the total voltage being applied. So at the peak, it's dropping 1/3 of 17 volts. At 0, of course, a 1/3 of 0 is still 0. And everywhere else along the line, it'll be dropping 1/3 exactly of the bigger sine wave. All right, so that's one way you can draw it. I'll be looking for some indication that you understand what the peak values are here, so like this 2-scale business, and also in the x-axis that you're using the frequency properly to show me that one wave occurs, one cycle occurs in between 0 and 0.01 seconds, for instance. All right, so that's question number 2. I'll cut us off here and do question 3 in another video. Thanks.